And welcome everybody to lesson number 4 on quadratic applications. A lot of physics will use quadratic applications as it has to do a lot with gravity and objects falling. So let's talk about quadratics and that type of stuff, right? A lot of times with quadratics, we know that we're going to need to be factoring, and we have different factoring methods that we've gone over, including completing the square. And one that we haven't gone over too much has been the quadratic formula, which I have right here on the screen for you. We have the quadratic formula we're going to need to use a couple of times today. As you can see, it's negative b plus or minus the square root of b squared minus 4 times a times c, all under the radical, all divided by 2a. Okay, so we're going to need this formula. If you need to take a second to write it down, go for it. Okay, so we will be needing that formula to help us out with some of these problems. One thing I will say about application problems is this. You have to know what the question is asking you in order to solve it. You need to know what part of the problem to use, and you know what numbers to use, and that takes a little bit of practice. So if you're not getting these at first, it's okay, it takes some time. Okay, let's go through the question and figure out what they're telling us. All right, this first application says that a diver stands on a platform 4 feet above the pool. He jumps with an initial velocity of 8 feet per second using this formula, which they gave to us, to determine how long before the diver hits the water. Now there's some things in here that we don't really know, right? T, which is going to stand for time in seconds. That's going to be our variable. That's like our x in most other problems. V in this situation would be the initial velocity. So they gave us 8 for initial velocity. So that V we're going to end up replacing with 8. So negative 16t squared plus 8t. And this s that they give us is going to be the starting height. So the starting height for this person happens to be 24, because they're 24 feet above the water. Now, we can draw a quick little diagram of what's going on. It'll always help. All right, we have this person up here. That's our diver. Okay, and they're going to be jumping into a swimming pool. And the height right here, to begin with, that happens to be 24 feet. Now what happens when somebody jumps, and it says they have an initial velocity, so now they're jumping up, they're going to jump up, and eventually they're going to come back down. Okay, so that's the path that this person is going to end up taking with their jump. Okay, we want to figure out how long before they hit the water. Well, if I think of this like my x-axis, where this person hits the water, that's just the root. So basically, if we can find the root or the 0 of this parabola, then we'll know how long, because our x-axis is going to be time. So we'll know how long it takes for that diver to hit. Alright, well, in this situation, I'm pretty lucky, because 16, 8, and 24, they're all divisible by 8. So I'm going to pull out negative 8 from this function. If I do, that leaves me with 2t minus t minus 3. I'm doing that because this is a little bit easier to factor. Right? I know I'm going to have a 2t, and I know I'm going to have a 1t. And I know I'm going to have a 3 and a 1 at some point. The question is, where are they going to go? Well, if I put negative 3 and positive 1, 2 times 1 gives me positive 2. 3 times 1, I'm sorry, negative 3 times 1 is negative 3. So I have a negative 3 and a positive 2. That's going to give me the negative 1 that I need. So by setting it up this way, I factored it correctly. It gives me the term that I need. Now, all we're looking for is when time, or what time it is when we're equal to 0, right? We want the height to be at 0, because that's when they hit the water. So if I take each of these pieces individually and set them equal to 0, that'll give me the time in seconds. Now this piece doesn't really count because there's no t associated with it. But if I take this t, 2t minus 3, set it equal to 0, and start solving, I find that it takes 1.5 seconds for a hit to water. I also have this t. If I solve for t here, I find that it takes -1 seconds. Now, -1 seconds, right? That would mean that they would have been in the water before they even jumped. So do we want to include that time? No, because we don't include negative time. That's before the person would have even jumped. Okay, so what we're looking for is a time after they jump, which is always going to be positive, so it's 1.5 seconds. So the question that they asked, how long before they hit the water, we'd want to write down, it will take 1.5 seconds to hit the water. Okay, so again, we had to know what they were asking for. If they're hitting the water, that would be 0 height, which would be 0 on the x-axis, or on the y-axis rather, so we're trying to figure out where on the x that happens to fall. Okay, so we've got to know what's going on with these questions. Okay, so we're going to look at another example. Okay, this one, you're standing on the ground trying to throw an item to your friend who is at a window a few floors up. You throw the item with an initial velocity at 68 feet per second. Okay, so you're chucking this thing up in the air pretty hard. They give you a formula, h of t equals -16t squared plus 68t plus 4 to answer the following questions. So they already gave us gravity, which is at -16t squared. They gave us our initial velocity, and they gave us a starting height. The reason why they give us a starting height of 4 is because when you throw an item, your shoulder is usually where you let go from, so they're assuming that your shoulder is about 4 feet above the ground when you throw. That's why it's not starting at 0, right? Your shoulder's a little bit above the ground. Okay, so the question here is, if your friend's window is 75 feet above the ground, will the item reach your friend? Well, think about it. Items go in a parabolic motion, right? A parabola. So what we want to know is, when we throw our item, if the highest point is higher up than this person in the window, right? If our highest point of this item is above the window, then it should be able to reach our friend if we have good enough aim. So we're trying to figure out the height, or the y-coordinate, of the vertex. Okay, no problem there, right? So first we want to find the x-coordinate. To find the x-coordinate, it's going to be the negative b value, so -68, divided by 2 times our a value, which is -16. Okay, that gives us -68 divided by -32, which is 2.125. If you need to use a calculator at any point for these problems, I highly suggest grabbing a calculator. Okay, that's our x-coordinate for the vertex. What we need to do now is find height. So I'm going to plug into the function 2.125. So that's -16 times 2.125 squared plus 68 times 2.125 plus 4. If you're using a school calculator, you want to type this straight in how you see it. If you're using your phone, be careful while you're doing these. I highly suggest downloading a calculator onto your phone, such as Desmos is a really good graphing app that you can use for this. Okay, so I use Desmos for all this. When I simplified, I ended up getting 76 0.25. Now that's height in feet. So the question here was, if the window is 75 feet above the ground and we throw our item 76.25 feet up in the air, will it reach that person? I think it will. Right? You're throwing above by 1.25 feet. So yes, it will reach. Again, that's assuming that you have good aim. Okay, we're going to be using that same formula, so we don't want to lose it. Okay. The next question says, if your friend doesn't catch the item, after how many seconds from when you threw it will you hear it hit the ground? Alright, well again, ground would be 0 height. So we're looking for when this function equals 0. Alright, I'm going to need the quadratic formula for this one. What I'm going to do is I'm going to plug in each of those values to the quadratic formula. So we want negative b, which would be 68, plus or minus the square root of b squared, 68 squared, minus 4 times a, which is negative 16, times c, which is another 4. All of that's under the radical, and we're going to divide by 2 times a, which is negative 16 again. Alright. Negative 68 doesn't change on the outside. You need to do this stuff in a calculator. Okay, 68 squared minus 4 times negative 16 times 4. So I did all of this into my calculator. I got 4,880. And 2 times negative 16 is negative 32. At this point, we have two situations, and I would suggest that you type in each of these situations in your calculator and decide which one you want. If I type in negative 68 plus the square root 4,880 divided by negative 32. And I'm going to have to do that carefully. But if I do that in the calculator, it's going to give me negative 0.05. And if I plug in the other situation, which involves negative 68 minus 4,880 under the radical, all divided by negative 32. Here we get positive 4.31. Why I'm telling you to type in both these situations is just like the diver problem. We have a negative time and a positive time. But can we have a negative time? No, it doesn't make sense. That's saying that that item would have been hitting the ground before you even threw it. We don't want to consider something that can't happen. So we're going to get rid of that. The answer that we're looking for is right here. So assuming that we threw that item and our friend missed it, it would take 4.3 seconds for it to hit the ground. Okay. So those are two application problems with quadratic. There's a third that I have prepared. I understand if these are difficult, and if you need to ask questions about these problems in class, please do so. Bring in your questions. I want you to try this one out, see how you do with it, and then you can resume the video afterwards to check your solutions. Alright, let's see how you did with this. Hopefully you didn't get too discouraged. I know that they can be kind of difficult. Okay, this one says that we have a new type of fireworks that's launching from a platform that's 2 feet above the ground at 480 feet per second. That's our initial velocity. So they want us to use this formula. Okay, they've given us this formula, negative 16t squared plus 480t plus 2, to answer the following questions. Let's do these one by one. Okay, the first question. If the firework is set to explode at 17 seconds, will the firework reach its potential maximum height? Meaning, does it explode before it reaches the vertex, when it hits the vertex, or as it's coming back down? That will determine when it's going to explode, right? Is it exploding before the height or afterwards? All right, so let's see. We need to figure out the maximum height. I'm sorry. We need to figure out the time that it reaches the maximum height, right? That would be the x value of the vertex, because as we had mentioned, time and x here are interchangeable. So we're just looking for the x value of the vertex. That's going to be negative b, which would be 480, divided by 2 times a, which is negative 16. So we've got negative 480 divided by negative 32. Those negatives cancel out. 480 divided by 32 is 15. So what did we just figure out here? We just figured out that at the highest possible point, the vertex, it takes 15 seconds. So if that means after 15 seconds it gets to the highest point, then it's going to start to come down. It takes 17 seconds to explode. So that means it's coming down for 2 more seconds before it explodes. So will it reach the highest point? Yes, it will. Okay, it's going to reach the highest point. It's going to explode on the way down. That was question A. Question B. What is the potential maximum height that the firework could reach? Well, we know it's going to reach it, right? Because it said it only takes 15 seconds to reach that height. We've got 17 seconds to work with. So it's definitely going to reach the height. Let's figure out what that height is. All we're doing is evaluating the function at 15. So we have negative 16 times 15 squared plus 480 times 15 plus 2. You could type this all into your calculator, or you could take it step by step if you would like to. That's completely up to you. I'm doing all these steps out just so that we can see exactly what's happening here. Okay, when we start solving, we end up getting a height of 3,602 feet. Okay, that's just evaluating. So we would say highest point is 3,602 feet above ground. Okay, we have one final question here. Problem C. It says if the firework is a dud, meaning it doesn't explode, how long will it take for it to return to the ground? Well, what comes up must come back down. So this firework shoots, it doesn't explode, which happens sometimes, and it starts returning to the ground. We're trying to figure out when it hits the ground again. Well, again, that's when our height is 0, so we're trying to figure out when this function is equal to 0. That means I'm going to need the quadratic formula again. Alright, so we want negative b plus or minus the square root of b squared minus 4 times a times c. All of that is under the radical, and that whole thing is being divided by 2 times a, which is negative 16. Again, you're going to want to use a calculator to do some of this stuff. Okay, I've got negative 480 plus or minus the square root of 230,400 plus 128, all divided by negative 32. Okay, if we type this in, there's 2 scenarios, right? Negative 480 plus the square root of 230,528 divided by negative 32. It's going to give us negative 0.004. Alright, so that's what we typed in. We got a negative. Think about it. Can't have negative time. That's before the firework was even launched. Doesn't happen that way. Okay, the other option is that we plugged in negative 480 minus the square root 230,528 divided by negative 32, and that gives us approximately 30 seconds. That makes sense, right? 30 seconds after it launches, it doesn't go off, it finally just hits the ground. That makes sense. So we would want to write, it takes 30 seconds to return. Application problems are tricky if you're not familiar with them, and they take practice to get familiar with them. So don't be discouraged. Don't quit right away. Give them some tries. Okay. Any questions you have, leave them in the comments or bring them with you to class, and I'd be more than happy to answer them there.